Hey everybody, what we're going to do is we're going to talk about molecular shape today using VSEPR theory. And VSEPR is an acronym, and it stands for valence shell electron pair repulsion, right? And what VSEPR theory is about is when you're talking about a molecule and how many what its geometry exists at, you're going to consider how many things it's doing with both its bonds and its electron pairs. This is a water molecule. And oxygen, the central atom, has two bonds and two lone pairs. They're not here, but they're not in the molecule, but they're there. All right. And these things repel each other because it's electrons, and electrons have the same charge, so they repel each other. So this repulsion basically dictates the geometry of the molecule, tells you what it's going to be, and it always goes to a minimum amount, minimizes its repulsion. All right. Now we're going to talk a lot about electric domains, and here's what they are. This is important. Single or double bonds count as one, and lone pair counts as a domain as well. And you're going to notice that some of the lone pairs will tend to take up more space and they bend the other ones. All right. So let's get right to it. First molecule has two domains and no lone pairs. This is the classic CO2, all right? You can see that molecule. This is known as a linear shape, all right? Now remember, we're talking about from the central atom here, all right? Now the second molecule has three domains and no lone pairs. This is boron tetrafluoride. This is known as trigonal planar. Okay, now three domains and one lone pair. This is an example of sulfur, or an example of this is sulfur dioxide. You can see sulfur's in the center. It has one lone pair here, and this is known as bent. All right, now you can see that this angle is 119. You're going to notice that carry through in some of the other molecules. Now, four domains and no lone pairs. This is tetrahedral, methane, carbon tetrachloride, carbon tetrafluoride. All right, the angle here is 109.5. Now, four domains and one lone pair. This is known as trigonal pyramidal. This is an ammonia molecule. It looks like this. There's a lone pair on the central nitrogen atom that sticks up and kind of squashes those bonds out of its plane, like you would have seen with the trigonal trigonal pyramidal. The next one is everybody's favorite and most well-known water molecule. All right, this has two lone pairs, but it's also known as bent. All right, now we're going to get into five. And five lone pairs looks like this. This is phosphorus pentafluoride. This is known as trigonal bipyramidal. All right, this bond angle is 90 degrees, and these bond angles in the center is 120. All right, that's what it looks like. I feel like this is like a virus. I'm sure you would agree. All right, there it is. All right, now when I get one lone pair, this is a fun shape. I got to construct it real quick. Here it is. There's a lone pair right here at the top of this central molecule, and you can see it kind of goes like this. It's got two pivot points that look kind of like a seesaw. This is known as a seesaw shape with five domains, four bonding here, and one lone pair. All right, there's a mistake there. It should say Cl4. All right, now when I replace one of those bonds with a lone pair, the molecule does something kind of fun and forms this shape, all right, which is known as, what letter do you see? big tall T, all right? And you've got a lone pair here and here, all right? Now, when I have 3 lone pairs, the name regurgitates again, and this is a linear shape. You can see where I've got a lone pair here and a lone pair here and here, but the shape of the molecule in terms of the central atom is linear. All right, now 6 domains and 0 lone pairs. This is known as tetrahedral. No. Octahedral, not tetrahedral. Octahedral, because I've got 8 faces on this beautiful shape. Now they're all 90 degrees. Should have made them out of chocolate. All right? All the angles are 90 degrees. Now, when I take one of these and replace it with a lone pair, it's going to look like this. And this is known as square pyramidal. All right? And the last one, when I take away 2, I get square planar. And that's it.